All right, last week we were looking at some simple perimeter questions. So we were given the task of adding up all the sides to find the perimeter. So those are for things like fences or picture frames or borders around something. Well, this week we're going to be solving questions that ask us about perimeter and area in the same question. So for today's task, we're going to be given the challenge of finding more than one rectangle that has the same perimeter but a different area. So as we remind ourselves really quickly, with perimeter we want to add up all the sides, every single one. With area, we're doing the inside, and that's where those invisible squares are. So we multiply because those squares make an invisible array. So let me give you the task I'm given right now. So let's say I was given the task to find two rectangles that have a perimeter of 20, okay? So I'm going to say they both want to have a perimeter of 20. All right, I'm going to show you two different strategies that you might use. The first one is kind of just guessing and checking. So I need these four numbers here to add up to 20. So I can kind of actually start an equation, 4 spots, because there are 4 sides of my rectangle. And keep in mind that with a rectangle, opposite sides are equal. So whatever number I put here is going to go here. So it's going to go on 2 spots in my equation. So I'm just going to pick any number and I'm going to see how it goes. So let me pick 7 and 7. So 7 plus 7 is 14, and then that's where I can divide up the rest of it. So 7 plus 7 is 14, and then my leftovers will go to these sides. But I need to divide it into two equal sides. So 14. And then I can just kind of do a quick 15, 16, 17, 18, 19, 20. But look at that, 3 and 3. Now, my drawing doesn't really make sense that 7 would be short and 3 would be long, but that's really not the point that we're doing here. What we're noticing is 7 plus 3 plus 7 plus 3 equals 20. Now over here, I'm going to find another 4 numbers that equal 20. These 4 will equal 20, but it's not going to be using 3 and 7. So here I kind of just guessed. I started with a number, and then I figured out what was left over. Well, if you remember from all year long, I kind of call these 3 numbers my lucky numbers because you guys have been using them since kindergarten, counting by 2s, 5s, and 10s. So that's something I like to just all the time start with. I love those numbers. They work really well for me. So let me start with 10, okay? Watch what happens when I do 10 and 10 here. Let me get my equation set up. 4 sides, I should have 4 numbers being added in my equation. All right, so if I put 10 plus 10 is already part of my perimeter, look at that, I'm already at 20. So this is also kind of using that guess and check here. 10 plus 10 is already 20, and that's not leaving me any more here. So 10 and 10 doesn't work. So I could use one of my other lucky numbers. Let me try 5 and 5. And I haven't used them over there, so I can try them here. So 5 and 5 is 10, and then the rest of it gets split between these two. So I have 10 already. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it was 1, 2, oh, look at that. That would actually be a perfect square if it was drawn as a perfect model. But we are just practicing. So we're not really looking for perfect, we're just looking for ways to work with numbers so that I have a rectangle with a perimeter of 20. Now remember, up here, it was asking for the same perimeter, different area. So we need to show them that these have a different area because we know that they both have a perimeter of 20. Well, my area is that invisible array, so that would be 5 groups of 5. So my area would be 5 times 5 equals 25. And over here, my invisible array would be 7 groups of 3. So my area would be 7 times 3, which is 21. So look at that, same perimeter, different areas. Okay, so those are two things you can try. Something else you might want to look at is, let's say that I could do a third one here. So let's say the perimeter needs to be 20. Well, some of you might have started to notice that we're using two sets of numbers, 7 and 3 and a 7 and a 3. So you might say, well, let me make this equal 10 and this equal 10, because this here equaled 10 and this here equaled 10, and same for these. So I know 3 and 7 make 10, 5 and 5 make 10, so let me do 6 and 4, 6 and 4. That's another example of 6 plus 6 is 12, 13, 14, 15, 16, 17, 18, 19, 20. Another perimeter of 20, but the area is 6 times 4, and it actually ends up being 24 squares would be in there. So that's another strategy you could use, is you could take the perimeter, divide it into two parts, and then share them by these pairs, kind of. The last strategy that I want to maybe show you, this is my favorite strategy here. But another strategy you might want to look at is, so let's say here, we just had a rectangle that is a 6 by 4, and then this is a 7 by 3. And you might notice a pattern here. I bet if these numbers are going up and these are going down, I bet an 8 by 2 might work. And I bet a 9 by 1 might work. And you might say to yourself, oh, a 10 by 0, but that doesn't make sense. So I might work the other way. Oh, look, a 5 by 5, and so on. And so these also would work, but I would really suggest drawing a rectangle if you're going to use this strategy also. All right, so use this video to help you practice when you are given a goal of having two rectangles with the same perimeter. That addition equation needs to add up to the same number, but that area multiplication equation needs to be different.